Okay, so what I wanted to do is show you how if you are able to go on to the Nearpod for the taking it all apart component. I just wanted to show a video that went over the instructions for that, just to make sure you understood it. Now, I'm not going to go through the videos themselves along the way. You're welcome to watch those on your own if you choose. But we did the activity in class, so I don't think it's as necessary as maybe if you didn't see the activity at all. If you didn't see the activity, then please go through and watch the videos. But if you watched the lab in class, then this should all be pretty self-explanatory based on what we did. Remember, characteristics of a mixture is that we can separate it physically. We can take it apart by evaporation, magnetism, filtration, physical separation, or picking things out, or distillation. A lot of ways we can remove things because they're not chemically bonded. They are connected at just a mixture. They're things together. Okay, our first question was, what are the easiest object to remove? You want to be able to remove only one item at a time. What item could you remove while still leaving the others behind? And then I kind of actually gave you this icon here about this. Kind of give you the easiest thing to do. A lot of people want to say, well, I get the gravel out because it's easy to see. But if I strain the gravel out, what I'm left with are the iron filings, the water, and the salt. I'm sorry, I'm still left with the water, iron filings, and gravel. So I would still have to separate these two. So the iron filings would be the first thing you have to remove. The first step, what I did was I swirled the cup around, and then I put the magnet in. We watched all the particles attract to the magnet. Watched how I pulled it off. They were all out. You can watch this video. It talks about how magnetism impacts if you had a different mixture, like with a dry mixture. But for our purposes, what we saw was that we were able to remove the iron filings from our mixture using the magnet. We were able to do that because metals like iron, nickel, and cobalt are attracted to magnets. We can use this attraction to remove the iron filings, and this is a mixture that we're separating apart. And then this is a separating a mixture using magnetism. So once again, we're able to remove the iron filings from our mixture using the magnet. We can do that because things like iron, nickel, and cobalt are attracted to magnets. So we were able to use that magnet to remove those filings from our mixture, and that's separating a mixture using magnetism. Make sure you click done and move on. Next poll. So now we have our gravel, our water, and our salt. We can only move one thing at a time. And again, what I did, I kind of gave you a key up here. Ooh, filtration. So what would I be able to filter out of that? Well, the gravel I could. I can filter the gravel out of there pretty easily. Remember that what I did was I placed the ring stand up and I put a funnel in there with a coffee filter. I placed the beaker under the funnel. I poured the mixture of gravel, salt, and water through the filter. The large pieces, the gravel, got caught by the filter, where the water and salt, which is a solution, made its way through the beaker. Again, you can watch that video on your own if you choose to. But after pouring the mixture through the filter, the gravel was left behind in the filter, while the solution of salt and water travels through the filter into the beaker below. They're able to pass through the filter because the particles are small enough to make it through the filter. And that process, they're small enough, let's put it actually there. And that process is filtration. It's kind of like making coffee. So I remove the gravel, I pour it through the filter, the solution of salt and water travel through the filter. The gravel gets left behind. But the salt and water are small enough. Remember, the particles of salt got broken apart or dissolved by the water. So they're really small molecules. They can make it through that coffee filter. They're small enough. And since I'm using a filter to do this, strangely enough, it is separation by filtration. Okay, so now we have only two more materials in our solution. It is a mixture, but it's a homogeneous mixture. So we also call that a solution. In our solution, we have salt and water. How are we going to separate this homogeneous mixture? Choose the method that you think will work the best. Well, we did magnetism. We didn't get it at that point. We already filtered it, and it made it through there. So I'm left with either evaporate the water out or pick all the particles of sand out or salt out by hand. If you look at the picture, it talks about using evaporation. So we're going to use evaporation or its distillation to remove that. And that's exactly what I did. I took the water, placed a small amount of water in an evaporation dish. I put the burner on. Waited until all the water was gone, and the material that was left behind was the salt. So after I evaporated the water, because water is what I can evaporate, the salt is left behind in the dish. The salt is a compound, or NaCl, sodium chloride, and can be broken down by, or cannot be broken down by physical means. Once I have it at salt, these are bonded atomically or chemically. I cannot break those apart anymore. The water that evaporated into the air still has the chemical formula of H2O because it's still water. Water is a compound. Just because I evaporated it, it doesn't mean I changed what it is. But since I evaporated it, that again is the process of removing or separating a mixture using evaporation. So once again, after I evaporate the water, the salt is left behind in the dish. The salt is a compound of sodium chloride, NaCl. Cannot be broken down by physical means because they're bonded as a molecule. The water that evaporated is still in the air, still has a chemical formula of H2O, and that's because water is a compound. I can't break down water either because they're molecules. I can't break those down. But this process of getting the water and salt separated out was the process of moving it through evaporation. And then you want to make sure you hit done. And this was the end. We had 3 questions left. There's a typo, but I don't want to refix it because I'd have to change the settings. So one of the characteristics of a mixture, is what that should say, is that it can be separated by physical means. That means things like filtration, evaporation, magnetism, separation allow me to separate that mixture out. At 2 points in our process, we had a homogeneous mixture or a solution. What was our solution? For an example, our solution, you can't see the particles and you have a solute, something that was dissolved, and a solvent, something that's doing the dissolving. And as always, if you look at my pictures, it says the salt is the solute, the water is the solvent, and the salt-water mixture is my solution. So the answer is right there had I looked. So I see it is the water and salt. Last question. Why are we not able to break apart the salt or the water by physical means? We don't have the right equipment. If I had really small tweezers, I could get those atoms apart. No. Salt isn't made of anything other than salt. Well, salt is sodium chloride, so we know it's made of 2 different things. But water and salt are compounds which are 2 or more elements combined chemically. That is the correct one because they are bonded at the atomic level. I cannot separate that through physical means. I would have to use chemicals, and throughout this lab, I used no chemicals to separate any of my mixture. If you have any questions about that, please feel free to ask. Otherwise, that should be the end of the slides. I hope you learned something about solutions, mixtures, and compounds, and I hope you have a wonderful day.